All right, we're going to look at a break-even point analysis again, but this time when there's multiple products being sold. Up until this point, we've been looking at single product scenarios. Here, we're going to look at multiple product scenarios, which is obviously going to be more common for a lot of businesses and therefore a little bit more in depth as far as the calculation here. So exercises 614 through 617 are based off of the question stem here you see in 614. So Angelone Manufacturing Limited produces parts for airplanes. Their main product offerings are airplane seats and airplane doors. Last year, they sold 300 airplane seats and 700 airplane doors. Below is the sale and cost info. So we can see the selling price for the airplane seat. It's 3,500, excuse me. So the selling price for the airplane seat, 3,500, $5,250 for the door. Variable costs were $1,250 for the seat, $2,750 for the door. Total fixed costs incurred for all of production was $3 million. Now, based off of this information, we're going to go through and calculate. For 614, we're going to calculate the weighted average contribution margin per unit. For 615, we're going to figure out the total units in order to break even. For 616, we're going to calculate the amount of airplane seats that have to be sold to break even, and then number of airplane doors to be sold to break even for 617. And you can see this is all connected here. So I've reproduced the information here that's relevant for this question. Again, nothing too crazy here. Selling price information is the same. Last year in sales, 300 for the seat, 700 doors were sold. Something that we have to calculate is the weight in order, or the mix, the percent that product makes up of total sales from a volume standpoint. The airplane seat made up 300 out of the total sales, which was 1,000 units sold. You can see 300 were the seat, 700 were the door. So the seat makes up 30% of the volume. The door makes up the other 70%. So what we do is we want to calculate the weighted contribution margin per unit for each product. So remember, how do we calculate contribution margin per unit for each product? We take its selling price. So let's look at the example for the seat. Selling price was $3,500. Variable costs were $1,250. So the contribution margin per unit of the seat was $2,250. We want to apply a weight or a factor to that represents how much of the total sales volume does that seat make up. It makes up 30% of total sales, as we just discussed here. So we're going to take and we're going to calculate this weighted contribution margin per unit, which is simply the contribution margin per unit of the product multiplied by the weight. You can see the formula there. The $2,250 contribution margin for the seat multiplied by the 30% weight. Its weighted contribution margin is $675. And we're going to do the same exercise for the door. We're going to calculate its contribution margin per unit, which is the selling price of $5,250 less the variable cost of $2,750, which gets us a contribution margin per unit of $2,500. It made up 70% of the volume of units sold, so we'll apply a weight of 70% to it. So to get its weighted contribution margin per unit, we take its individual contribution margin per unit, which was $2,500, multiplied by 70%. So its weighted contribution margin is $1,750. Total fixed production costs, they told us, was $3 million. Now we can get into the specific questions. So exercise 614 asked us to calculate the weighted average contribution margin per unit in total. And all that is, it's adding up the weighted contribution margin per unit of each product. In this case, the weighted average or the weighted contribution margin per unit of the seat plus the weighted contribution margin per unit of the door. So the $675 weighted contribution margin of the seat plus the $1,750 weighted contribution margin of the door, that gets us a total weighted average contribution margin of $2,425. And the reason we calculate this number is because that's what we use to do our break-even analysis. And you'll see the formulas are very similar to when we did break-even analysis in a single product scenario. Break-even in units is total fixed production cost divided by, in this case, weighted average contribution margin per unit instead of contribution margin per unit when we did the single product scenarios before. So how do we calculate break even in units? We take the total fixed production cost, which is 3 million, and now we divide it by that weighted average contribution margin per unit, which we just calculated to be $2,425. So in total, this is of all the products we sell, in this case, the seats and the doors, in total, we have to sell 1,237 units. Now, we don't just stop there because it doesn't tell us, okay, how many of the seats do we sell? How much of the doors do we sell? It just says in total how much we're going to sell. We do want to know that specificity. We want to know the number of airline seats we have to sell. Of this 1,237, how much has to be seats and how much has to be doors? And that's when we get into exercises 616 and 617. There is an assumption here, and the assumption is that this weight or product mix is the same at break-even point. In other words, in order to break even, we have to sell 1,237 total units. The assumption is that 30% of these units are the seats and 70% of those units are the door. So in order to break even, if total sales is 1,237 units, that means of that 30% or 371 are going to be airline seats. So we just take the total break-even point in units, we multiply it by, we multiply by the weight allocated to the seats, which was 30%. So 371 of the 1,237 is going to be seats. 70% of this number, the 1,237, is going to be the doors. Because again, the assumption is that this mix, this weight, will remain constant.